Okay, so we are looking at this style of question today. So this is the function that we're given. We're told that if we integrate between here and here, then we get this many units. If we integrate between here and here, we get that many units. So I've compiled that information down here and just shown what that was stated as. So now we're just going to integrate, and then we'll end up having to solve using simultaneous equations. So if I integrate this function, I'll end up with ax over 3, or ax to the power of 3 over 3, plus bx squared over 2, plus 4x. And remember, because we're integrating between boundaries, we don't need to worry about c. And I'm going to write the same thing again for the other side, but we'll be integrating with different boundaries. Okay, so when I substitute 0 into the equation first, I end up with 0. So all of those parts will end up as 0. So it's going to be 0 minus. When I substitute negative 1 in here, I'll end up with negative 1. So it'll be minus a over 3. Plus here it'll end up being positive 1. Plus minus 4 when I substitute it in there. And that will be equal to 13 over 6. So this negative out the front will change all the symbols inside, making it a over 3 minus b over 2 plus 4 equals 13 over 6. I'm going to keep running through with this one until I can resolve it into a is equal to something. Okay, so now the next thing I'm going to do is take the 4 to the other side. And to make them have the same base, so I can add and subtract them, I'm going to put them over 6. Now, I'm going to make this side over 6 too, and you'll see why in a second. It's going to make my life doing the algebra way easier. Okay, so that's going to end up with 2a minus 3b. Now, that whole thing is over 6. So if I take this 6 up to the other side, then it's going to cancel out this denominator of 6. And so I'll just be left with 2a minus 3b is equal to 13 minus 24, which will be negative 11. Okay, so from there, now I can get my expression into a equals. So first thing I'm going to do is I'm going to take the 3b to the other side. Then I'm going to divide everything by 2, and that'll just give me a. Okay, so now I'm going to do the same thing for this side, and I'm going to substitute a in. That will resolve what b is. Okay, so when I substitute 1 in, I'll end up with a over 3 plus b over 2 plus 4. Now, here we've got 0, so that'll just be subtracting 0, so that's not going to really change anything. Equals 43 over 6. Take the 4 to the other side, and then I'm going to make everything have the same base over 6 so that I can multiply and get rid of this. So when I take that up over to this side and I multiply everything by 6, it's going to cancel these 6's out. So let's write that neatly of what we've got left. 2a plus 3b is equal to 43 minus 24. So that's going to be 9. So that's going to be 19. Okay, and now I'm going to substitute this in as a. So 2 bracket minus 11 plus 3b over 2 plus 3b equals 19. This 2 is going to cancel out that 2. Now I can group my like terms of b together, and I can take the 11 to the other side by adding 11. Now I can take the 6 over by division, and I'm left with b equals 5. Next thing that I need to do is substitute b back in over here, and that's going to give me my final answer. So negative 11 plus 3 times 5 over 2. 2 times 5 is 15, minus 11 will make 4. 4 divided by 2 is 2. So now I found that a is equal to 2, b is equal to 5.